This topic I've already presented last year in ROSCON, but there are some new additions which I wanted to talk about. So the context for this is that my group is basically working in software engineering within the context of robotics and or specifically in ROS, and we are creating tool chains for software components deployment and also kinematics, which I am specifically working on. So today I'll be speaking specifically in terms of kinematics. I'm sure you have heard this topic like hundreds of times. Probably a lot of people have moved away from this topic because there is no deliberation happening in this area. But I'm not specifically focusing on what new tags to be introduced in URDF, like simulation or those kind of things. There are three main challenges what I'm looking for, which is basically what will be expanded to other aspects of ROS as well, like software components or deployment, as I mentioned. So three, let's say, challenges what we have identified is basically the standardization within URDF or also Xacro, documentation of what components exist for kinematics in the ROS ecosystem, and the tooling surrounding URDF Xacro. And most of these challenges I'll try to solve using MD-based solutions. So the first one was basically there is no real standard. There have been some experiments done where there is an XML schema which exists back in 2013, but there is no real use case for it. So the only, let's say, schema that exists is a very old wiki page, and probably the schema is kind of inbuilt into the headers of URDF, like links, joints, and whatever exists. So based on that, you might think that this is the schema for URDF. Also there, every time you try to, let's say, upgrade URDF with a new feature or a new tag, how do I support, let's say, my parser, right? So to overcome this challenge, versioning was introduced, I think, like 2 or 3 years back, but I don't know how well that has been integrated into the parsers, into the existing URDF files. Also, there is no information about it on the current wiki pages, for example. So maybe the discussion has happened on one of the discourse discussions or probably on one of the GitHub issues. And lastly, basically, the specification versus parser discussion, right? So in case of URDF, the C++ parsers, basically the URDF DOM is where the parser is located, and the headers are basically located in URDF DOM headers, which you could consider as a specification. And also, as I said, there is an existing XSD file which has never been used, basically. Lack of documentation. Again, I'm not talking specifically about the specification itself, but let's say there are very few commonly used kinematic components, let's say for example, UR5 or ABB robots, and you see a lot of examples out there. So you can use UR5 Xacros to do the composition. You exactly know how to instantiate the UR5 macro. You know how to set the parameters for that. But imagine if a new description package exists with like 10s and 15s of Xacro files, and that is the case sometimes. You'll have to go through the entire Xacro file, maybe 100, 200 lines of code to identify, I don't know, which macros to instantiate, what are the root links you need to use for the composition, what are the connection points, what is, let's say, the origin of my child link with respect to the base link, stuff like that. Also, what are the different components provided, let's say, for ABB or some of the cameras, where you see there are multiple Xacro files in these description files. Also, recently you'll get to see questions like, where can I find all the sensors URDF files for sensors, for example? Or is there one common repository which holds all the components where I can easily search through all of them? And lastly is basically lack of tooling. Yeah, again, if there is a newbie who is just introduced to ROS, or system integrator who are not so well versed with using Xacros, probably URDF is much easier. But understanding Xacro syntax can be hard if you are just getting introduced to ROS, right? So also the Xacro parser doesn't give very understandable error. It will just show you that the XML is not well formed or something like that. There are always multiple tools you need to use. First you need to convert it to Xacro, then you have to upload it in RWiz. Then you probably need to use check URDF to see if your URDF file is valid, so on and so forth. Also, there are a lot of rep files available. Heis has created one, and there are some other rep files. Again, they are not specifications, but let's say best practices. Just by looking at a Xacro file, probably you wouldn't know if my serial manipulator is following all the reps meant for serial manipulators, right? You'll need to identify by reading this large XML file, for example. So on the lines of these problems which I just mentioned, recently a researcher from Aarhus University in Denmark, I think, did a survey with about 500 or so robotics engineers with different levels. Some of them were pretty beginners, some of them were also experts. Quite a few interesting results. One of them that caught my eye was this one, which also mentions the few of them at least, the challenges what I mentioned in the previous slides. Yeah, again, the versioning is missing, better tools to validate or do the composition, visualizing your complete robotic system, for example. Yeah, so basically MD has been a very old topic in our group. So first thing I looked into, of course, was using one of these technologies, which was used initially for software components, but yeah, I thought why not to use this for kinematics as well, because the advantage in case of kinematics is that we already have a model that in case of, let's say, URDF, or I don't know, Xacro can be called a model, but at least URDF is. And yeah, using MD, you can basically create very nice developer tools to work with, right? So they are basically less error prone. You can do the introspection at design time. So as soon as you type a wrong syntax, it will already show you an error. And it also captures the domain knowledge. So in this case, domain knowledge would be probably URDF, which is what I mentioned, that the models already exist. So why not try to use MD tools for kinematics as well? Yeah, I didn't want to go into too much detail about the implementation part, but just want to give you a very quick overview. Is that basically on the extreme left, we basically have a meta model, a fancy word. And based on that, we are basically trying to auto-generate the header files and use those header files for the parser. And once we use, let's say, parse in the Xacro files or URDF and create a component database where you can easily search through, visualize, see what are the components available, so on and so forth. The same meta model is also used to create a tool which is basically an IDE. In this specific case, it's an Xtext based language server, which will give you features like code completion and so on and so forth. And the third aspect, I would say this is kind of a hack. That's why I haven't created a separate slide for this, is that I'm creating from the ECore model, converting it to a JSON schema, and using an existing tool, you can create an HTML page for the schema itself. So currently, as I said, there is just one static wiki page, which is very old. But in this case, probably as soon as you make updates to the ECore file, which is basically in our case, let's say an addition of a new kind of joint, for example, in the ECore model. You just need to run this tool and it will update the HTML file. So you have basically, you can also integrate probably this into a CI, for example, right? So I just need a visualization tool to make changes into the ECore file, and immediately you have the schema HTML page already available. So I'll try to split each of the blocks which I showed you in the previous one. Is that, yes, looking at the first part is creating header classes. So in this